Given that s is equal to t squared plus t minus 12 is the horizontal displacement of a particle with respect to the origin, with t the time in seconds and s the displacement in meters, we want to find the initial position of the particle and its position when t is 4. So initial position means t equals 0. Initial means at the start. So we can see that that's at negative 12 meters. We then want s of 4, so when t is 4, that's going to give us 4 squared, add 4, minus 12. So that's 16, and 4 is 20, take away 12 is 8 meters. We want to find when the particle passes the origin. So it passes the origin, if we just think about this for a second, so it's moving along this straight line, and the origin is here, and all distances are measured from the origin. So, for example, our initial was over here at 12 to the left, and this one was 8 to the right. So to be at the origin, we need s to be equal to 0. Its distance from the origin is 0. So that's t squared plus t minus 12 equals 0. We just need to solve the quadratic. So that's going to give us t add 4 and t take away 3 is equal to 0. So t is negative 4 or t is 3. Now we can't have that. The stopwatch starts at 0, so it passes the origin when t is equal to 3. Sketch the displacement function for t between 0 and 5. Well, there's a couple of things we need to know here. So s of 5 would be handy. 5 squared, add 5, take away 12. That gives us 18 meters. It would also be nice to know if there's a turning point between here and here. So in order to get that, we'll do ds dt, and that's going to be 2t plus 1. So we need 2t plus 1 to be equal to 0, and that would give us t as negative 1/2, and again that's not an allowed value for t because we start the stopwatch at 0, so we know that there's going to be no turning point. So we just do t along this way. Let's make it 1, 2, 3, 4, and 5. So we know at 0 it's down here at negative 12. Crosses the axis here, and we know it's 18 at this one, and we know the shape of a quadratic, and it's always sloping upwards because we know the turning point was over here somewhere. It doesn't exist, so that's going to be our function s against t. I'll just mark on there that that's 18 at the top there. So when is the particle to the right of the origin? Well, whenever the displacement is positive, so that's for t greater than 3. When is the velocity negative? Well, never, because if we continue this backwards, yes, there's a turning point here, and this would indicate that the velocity is negative, but here it seems to be travelling always in this direction. Remember, velocity is the gradient of ds dt. V is equal to ds dt. Here the gradient is always positive, so never. And when is the particle stationary? Once again, the velocity is always positive, so in this range, never. And in fact, if we went on beyond t equals 5, this would just become more and more positive. So because the turning point was back here at a time that can't exist, the velocity was never 0 and never negative.